Hello and welcome to Java with OC. Today our topic is objects and the object library and Java standard libraries and how do you use one and what even are objects, because that doesn't make a lot of sense. Now some of you might be old programmers of like COBOL and Fortran and Pascal and BASIC and things like that, where it was a more procedural based system. The idea there was you write a set of code and you may reuse it a few times within one set of code, but so you would write a procedure for it or something to the effect, and you would just use that whenever you needed to. And that worked all well and good. However, in the idea of object-oriented programming language, like Java, C++ is an object-oriented as well, so is Python now. And so the idea here is that if you create code that represents an object, a thing that exists essentially, and that thing could be very literal, like an object. For instance, objects could be things like a Hitachi 18-volt power screwdriver with rotating head, adjustable screw strength, and 1.4 amp hour battery. I mean, who doesn't want one of those? This object can do things. This object can drill, can screw with the right attachment. It can reverse out. It can exchange its battery. You can pull a trigger on it. There's lots of things that you can do with it. It could be objects like this that send you back in time, forward in time, through space, and all different things there. You could have a sonic screwdriver that somehow works in some sci-fi fantasy. Or you could have an object that's even very real to us, like an R8. We all know that we all drive these. Obviously, we all have that kind of money. And this as an object. This is an object that can go forward, backwards, windshield wipers turn on. You can have headlights turn on. You can have doors open, trunks open, gas tanks open, go fast, go slow, brake, things like that. Those are all kinds of objects. And Java has a bunch of these already programmed in for you that you can use already. Okay? And there's a whole bunch of libraries of these things that you can use, and we'll get into that in a second. But let's talk about an object first and what it looks like in code. Because, okay, I understand that there are these R8s out there. I understand there's power screwdrivers out there. And I can believe you, OC, that when you say that there must be objects already pre-programmed in that are used all the time. But what does that look like? Okay, well, let's look at a piece of code that I'm going to create here. Okay, so here's one where I'm just going to create some code. Again, the program itself probably has no real meaningful use. It's proof of concept, proof of the existence of what I'm talking about. So right now you've probably used things like ints, int x, y, weight, height, level, things like that. Okay, and you could assign values to these things. These are primitive types, so I can assign, x equals 5. I can say y equals negative 100. And what you're doing there is you're setting up primitive types, okay? And these primitive types take up a certain memory location that are now assigning certain values inside of them. That's very primitive. They can't do much. X is assigned the value of 5. That memory location has the number 5. Woo, yay, okay. That's good for doing stuff with, but right now, I mean, that's not really an object. There are objects of those things, but not yet. Not the way we did it. So what's an object? Well, one that you probably have used and unknowingly have been using is the string object. So we'll say string name equals OC demand. Okay? That's an object. What now? Wait. Why is that an object, but X and Y aren't objects? I mean, isn't that just, some letters? Isn't a string just a, kind of basic type of things? Yeah, I agree that if you think of it that way, it is a very primitive kind of characterization of things. In fact, you could say a string is what we call an array of characters. Array is something we'll get into later. So, I mean, you might say, well, that is a composition or a making up of a bunch of primitive types. However, there are things we can do to strings. For instance, let's say I want this instead. I mean, come on. Why are we saying this lowercase? I want to say this uppercase. So I want to say, okay, system.out.println, and I want to print out the uppercase version of that string. So instead of printing out, well, I could say name, and that'll print out just good old name as it is there. Well, what if I wanted to actually, print out the uppercase of that? Well, then what I would type after this is name dot, and that says I want to use a method of it. Okay, and the methods are behaviors. Okay, just like we said a second ago that that objects have behaviors. For instance, you can pull the trigger on this. This can turn. You can exchange things out. The car can drive. The car's doors can open. Things like that. Same thing's true inside of of a string. A string has things we can do, behaviors, what we're going to call methods. Okay, and methods can be accessed by using a dot after the name. So when I say dot, I'm accessing a method. So technically, you've been doing some dots earlier. Println is a method of the system out object. Dot doesn't always mean method per se, but in that case it does. Okay, so I'm going to call a method of strings called toUpperCase, and I put parentheses after it. The anatomy of calling any method is the object name, and I don't mean literally the word name, but whatever you call the object. I mean, if I call this string Rudolph, Rudolph, okay, then these would be not named, these would be Rudolph. Okay, Rudolph. Definitely picked a bad word for a name there. Okay, so, I'm just saying the name of the object, the reference you've given to the object, because this is called a reference. This reference to the object, dot, that's the signal to Java. I want to use one of the methods of this object. toUpperCase is the name of a method of that object. Okay, so then when I run this and I look down here in my output screen, I see the original string, OC_demand, and then OC_demand. All right, toUpperCase. And again, if I print this string out afterwards, we're going to notice something really kind of neat. So let's print it out again and run. OC_demand, OC_demand, OC_demand. Strings are immutable. What that means is when I create a string and I say, that's a string, that's the string, and we'll reference that string by the name Rudolph, okay? And reference means that I'm pointing to an object. More on that later, not a big deal right now. But essentially I'm saying, hey, that's the object right there. I can't change that object permanently. So when I print out Rudolph and it says OC_demand and then I dot toUpperCase, that gives me a brand new object that is OC_demand. Okay, because later on I print out Rudolph again and it's not uppercase anymore. Because this temporarily uppercases it, you could think of, but really what it does is it gives back a string that is a new string that is the uppercase version. For instance, if I want to store permanently an uppercase version, what I might say is like string UC for uppercase name equals Rudolph dot toUpperCase. Like that. And then when I print out this a couple times, so down here I'll go print it out a few times. So system.out.println UC name and system.out.println. Let's say I want to do the lowercase version of this name. So that's a method we call dot to lowercase. Okay. And then I'll system.out.println that one more time to see what happens afterwards. And we'll see what happens here. Okay, so on this one, I guess I should have been nice to do a couple print lines that were spaced out. My apologies here. And so here I have the uppercase version. I actually stored the uppercase. So UC name essentially was assigned the uppercase value. In this case, this gave me the uppercase value, but never rewrote what was in Rudolph. If I wanted to permanently change what was in Rudolph, I'd have to do the same thing here, like I did up here with UC name, and say Rudolph equals Rudolph dot toUpperCase. And so that would get the uppercase version and reassign that back to Rudolph. Remember, we talked about assignment is one of the lowest operators that occurs, and it's the last operation to occur. So that will actually assign after the uppercasing has occurred. Okay? So you might think, well, that's good. Oh, man, that's awesome. I can uppercase stuff. That is so amazing. Well, what else could I do? Well, you can do different things. For instance, let's say, let's get rid of some of this stuff here and let's work just with Rudolph again. And let me change Rudolph to something simple again. So let's go to name again. All right, and so let's say I just want to print out a character. So I want to get the first character here. So I will say name dot char at, and in the parentheses here I'll put 0. Okay, what that references is this references the index of which on which you want to get the character. A string is a collection of characters, and this collection of characters, or an array of characters, is referenced by an address. Each address has its own character. So this is address 0, this is address 1, address 2, address 3, so on and so forth. Counting in Java starts at 0, does not start at 1. So this is index 0. Okay, so when I say char at 0, give me the first character. Okay, give me the first one. All right, I can also print out the length of this string. So if I want to say system.out.println name.length, I can get the length. Okay, and we can compare these two. So I'll sit here and do this, and O is the first character, 9 is the length of the string. Okay. Something else I can do is I can cut out portions of the string. You know, I like the man part, but I don't want OC duh in it anymore. So what I can do is I can use another one called substring. Okay. And in substring, I can provide two values. The first value is where to start at. So for instance, if I want just man, I could say, you know, O is 0, 1, 2, 3, 4, 5, 6. So I can start at 6. And I'm going to go to the end. So you're like, well, the end's the length, right? So why don't I say name.length? Okay. So that'll cut from the beginning of where man starts to the end. So let's see what happens. And I got man. Okay. So I got it all the way up to length. Okay. And do you notice how it cut, you know, it didn't cut, you know, to the length? Because the length is 9. Let's think about the indices. Here we have 6. And then A is 7, and then N is 8. But length says 9, so why didn't that cut to 9? Because they know that length is going to be one more than the last index. So when you substring is defined in such a way, it goes to whatever this number is minus 1. So if I actually put in 8 there, because I'm thinking I need 6 to 8, which is 6, 7, 8, that should cut out man. Let's check. Look at that. Just ma. You calling for your mommy. See, that didn't work. Don't call for your mommy. That's not going to work. That cuts one less than the index what you're looking at. So if I put 9 in there, that works fine again. I get MAN. But then again, what if this wasn't that string? What if I wanted the last 3 characters every time? So right now, that'll cut out 6 to 9 every time, so I can go hello, 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 and it won't give me the last 3 characters. It'll just give me these 3 from 6 to 9, not inclusive of 9. So if I want to get from 6 to the end, I could just say name.length, and this will now automatically size to the length of the string. See, now I get man, hello, hello, hello. All right, and the length is now 29. So it's kind of a dynamic change of the variables.